Hi, welcome back to the videos on relations, and in this video I'll talk about just understanding some basic things with regards to if you have tables or if you have some graphs provided to you, what exactly to gauge from those tables or graphs in terms of trends, how to kind of extend interpolation and extrapolation from data if something is missing, or if you want to be able to kind of project things into the future and guess. And I'll show you some things to watch out for in reality, because when you're studying, especially when you are in, let's say, in grade 9 and you're just beginning this information, you always assume that everything kind of works out in that way. Well, it's not always true, and I'll show you an example of that from actually the stock market. Okay, so sometimes our interpolation or extrapolations don't exactly work, okay, in real life. Okay, so let's begin. Now, scatter and bar graphs, as you see there as the title, we have talked about in the introduction. So I'll link the introduction up above. And then we kind of walked through numerous ways of being able to collect data, okay, various ways of data sampling that we can do. And from those collections, creating hypotheses, for example, and then trying to prove or disprove those, that particular hypothesis that we might take up. Now, in here, what you see is I will provide you this kind of little table that you have. And in this table, it has months, except it's starting from September. It doesn't really matter in which year this is. Okay, so let's imagine you have September, October, November, and so on. So it's basically a data sample per each month that we have, and then it says time in seconds. Now, in reality, what you would have to label this so that somebody actually knows and understands what you're doing. So I'm going to actually tell you, okay? So this sampling is basically, let's say, for a 14-year-old swimmer who is being timed, and the best times from the month have been picked. And then they have been recorded, okay, for each of those months. So they started their season in September, okay, so that was that right there. And then they continued on, so from September, October, November, December, January, February, March, and April, okay? And let's take a look and see what happens with that. Now, from some of the previous videos, you should be able to now understand which is the independent and the dependent variable in this case, so that if we are, for example, plotting this on a graph, and I'll use a scatter graph, okay, to plot this on. And for this particular set, okay, so our months are going to be our independent variable. It's going to be on the x-axis, and our time, okay, in this case it's in seconds, are going to be on the vertical, and that's going to be our dependent variable. All right, so let's take a look and see, and then we'll talk about, okay, the trend that we are actually seeing, what is happening, how we can pick it off. Then we'll try to see if there's some information in that sample, okay, in terms of the graph that we can analyze in some way. So here is the graph that I'll draw out here for us. Okay, so we have our x and our y. All right, so we have it in these directions, and I said that the bottom, okay, so this will represent our months that we have, and I'll try to space them out relatively equally. All right, so let's say September, okay, October, November, December, okay, so January, February, March, and then April. All right, so that's what we have. And on the axes, so in this case, okay, I will actually take a look, okay, and I'm going to cut this off a little bit to make it, okay, and draw it like this. And what that means is that we're simply cutting off our data, because notice that these times, as you're noticing it, they're kind of in the 60-second range. So if 0 is all the way at the bottom, okay, so we're going to be starting it up, okay, and I'll try to do it in some way. So let's say we'll start it off here, okay, and that will be our 60. And let me erase these, okay, from the side, so that we have a nice okay, set here. So let's imagine this is 60 seconds, all right? And the highest number that we have here, okay, on scale here is 66.2 that I see. So let's just kind of nicely stretch it out, okay, and then put this at 70 seconds right there. So that will be our time. And then we can nicely capture these in between somewhere. So I'm going to say, 61, 62, 63, 64, 65, 66, 67, 68. Okay, and let me kind of make this a little bit higher. Okay, so 70 will be here. Okay, and this would be 61, okay, and so on. So we have that mapped out for us. Now, if you're drawing this, you can definitely put in the time, okay, to try to draw it out nicely so that you have them spaced out. And in terms of our months, okay, that we have in here, so if I'm going to put the months over here, so I said that we're going to be starting here from September, and those are going to be our months here. So I'm going to just write S for September, then October, November, December, January, February, March, and April. Okay, and with this, okay, now we can actually plot our little graph. So I'm going to take purple and plot it in. So I'm going to take September, it was 64. So it was 60, 61, 62, 63, 64. Okay, so let's say it was somewhere around there. Okay, so that would be one, okay, of the points. Then we have 64.5 in October, so it went up a little bit, okay, in October. So we have that. Then we have 63.1, so it drops down a touch, just a little bit above there. All right, so that would be that. Then in December, we had 62.2. Okay, so again, we're noticing that it dropped there. Okay, so this was 62.2, so a little bit closer to there. Then in January, dropped again to 61.6. So that will be somewhere over here. So we're noticing a trend that it's kind of coming down the times. And I guess if this was a swimmer and they were training, so maybe over the duration of the season, they were lucky enough, okay, that they were able to improve their times. And maybe this was like a 100-meter sprint for them, okay, in terms of freestyle or something like that. Then in February was 66.2. Oh, so this one kind of skyrocketed up. So it'll be 60, 61, 2, 3, 4, 5, 6. So this one is going to be somewhere along here. Okay, so this really jumps off at us and then it comes back. So 61. Okay, so this one is peaked right back down, and then 60.5, okay, which is right here. So this data nicely shows quite a lot for us, and we can see what is happening in terms of a trend, okay, for this. So if we're talking about kind of trends, interpolation, and extrapolation from this, so a trend is basically something that you can tell from the graph what is happening. Visually we can tell that the actual swimmer is getting better, okay, so their times are coming down, so they're getting faster. Now we don't know what's going to happen in the future, but at least for this one, okay, so we can kind of see that in here. Now, one of the data points, notice, okay, so this one, I'm going to highlight it in here, okay, so the 66.2, okay, which has come from the February results right here. So what could have possibly happened, now we can kind of think maybe the swimmer was sick, because this does not follow the actual trend at all. And if that happens in the data where something is really off from the data, we call this an outlier. So this particular point would be called an outlier. All right, it lies outside, okay, of what the normal trend would be. Now you have to be careful with these outliers because they're sometimes very useful information. And the unfortunate part is that sometimes these outliers lie somewhere and people just kind of forget about them and say, you know what, this was a measurement that was maybe the timers were off or something like that. But the reality is maybe the swimmer was actually sick and wasn't performing as well as they could in the previous months or in the months that happened after, because notice the trend continued there. But those outliers you should know, okay? And as you're studying this, okay, you kind of should know what an outlier is, okay? So it's a point that it's outside of the range. So we have this scatter plot, right, or scatter graph, and we're seeing these trends. Now, if that outlier wasn't there, right, and let's say we knew that the swimmer was sick, we could have interpolated. So interpolation, it means that we are taking, okay, a guess between two data points. So since we did have this nice outlier here, so I'm going to show you and kind of project out interpolation. So this is, interpolation is always somewhere within the data. And one way to interpolate, okay, so to try to find a point between data points that you already have, is through taking some kind of an average. All right. So for example, we knew within here, okay, so the January and then the March, okay, so points. So we had 61.6 and then we had 61.0. So those were the actual points. Now, if the swimmer, let's say, was continuing on the same trend, we could just take the average of the two. So for example, we would add it and then we would divide it by 2. Okay, so 61.6 plus 61, okay, divided by 2, and that would be 61.3. All right, seconds. That would be an interpolated data point, where you're basically guessing the point and assuming that the trend kind of continues. And if you were plotting this in there, it would have been plotted somewhere over there. All right, so as I kind of zoom in here, okay, so it would have been kind of there. So that outlier wouldn't really be of value to you. Okay, so this would have fit the data much nicer. But again, that's not always reality, right? Maybe the swimmer was actually sick and you weren't interpolating. So interpolation is always done in some way where it is between points that you already know, or data sources that you already know. Now, extrapolation, okay, you're extrapolating outside of your data. All right. So in this case, for example, we have this data and it's only up to April. And interpolation would be anything between September and April, where you are interpolating it somewhere in between there. But extrapolation would be something outside of that data scope. So that means it is completely outside of that range. So maybe you wanted to find out what happened in May and in June. And assuming that this trend continued, you can kind of guess maybe, okay, that what you would have, okay, in here is that these data points would continue, and let's say maybe the swimmer continued to get better, right? So if we are interpolating this, okay, then it would be between September and April. But if we are extrapolating this, okay, so then that data point maybe would have fell somewhere, okay, in the range right here, okay, and then it would continue this trend. Now, how you can do that is you can kind of fit a line through the entire points to see kind of the line that fits best in between here, and then see what actually happens. All right, so here is an example of that, and I will talk about that also in a future video, okay? And that example would be, for instance, something like this. So that we would kind of try to draw this. I'm going to try to draw and now fit kind of the best data point possible, or the line possible, kind of something like that. All right. And then what I can do is I can say, okay, so in terms of extrapolation, okay, if I continued, maybe that extrapolated points would fall somewhere within here. All right. Okay, so that's what you would have. It's a guess. Swimmers or athletes are not going to get really, really good all the time, where their times keep coming up. They may plateau at some point or stay, or sometimes get a little worse. So that depends. But in terms of these data sources, at least this way now you know the difference between interpolating and extrapolating. So interpolating is data that you are guessing in between points, and that can be done through averages, as I have done right here. It can be done through just simply taking a best line of fit and then taking that point there. Notice in this case, it just so happened that our point kind of fit there right on that line. It was just a guess. And extrapolating is when you are guessing outside of the range of your data. All right. And now clearly the trend is that this swimmer is getting definitely better. So that's what we can see, at least for that duration of that season. All right. So that's that. Now, I do want to warn you, when you are working with these scatter plots or bar graphs, right? So we could use bar graphs in certain situations. Scatter plot is much better in this case. And now here is a different data point. Okay, so this one is actually real data point. And notice, so what I have is I have dates, okay, on this side, and they kind of look like they're going back in time. So what I'm going to do is, okay, we're going to take these dates, okay, and we're going to move in this direction. So notice from September 1st to September 21st. And these right here, so all of this information that you have in the other column right here, let's say this would be your price. All right, so that is the price in dollars, and this is just simply the date. Now, what date? That's pretty simple. Okay, so it's from September 1st to September 21st on different days. And money, so this is actually coming from the stock market, and it was the price of Tesla, okay, the stock, from that time period. Okay, so during September 1st all the way to September 21st, and during the closing times. And notice I purposely left out a data point there on September 8th. So you can see that in there. So on September 8th, I didn't put a data point there. And I just wanted to show you that when you are interpolating, you know, how dangerous that could be. So, you know, when you have this data sources, you know, we could definitely plot this along, and you will notice that it won't be such a nice plot. You know, it's not like a trend going up or something like that. So from September 1st, you will notice that it was 475. And then it went down to 447, went down again to 407, okay, 418. Now we don't know a data point, okay, then it was 366. Then it started coming back up, 371, 372, and then all the way up to 449. So it kind of has this U pattern, right? U trend, okay? So if we would be plotting this, and in this case, if we had a plot of that, so let me just do this. Okay, whoops. So let's do that. And now we were plotting this, and the date, okay, was our independent variable on the X, and then money would be our dependent variable. So it would kind of look like this. So it started at 475.5. Okay, so it would kind of look something like that, right? And then it would start looking right back up. All right. So that's how it would kind of look like from that September the 1st, and then it would be going off to September the 21st. All right, so that's what you would have, and that's how it would look like. So for this, okay, if you're looking at this, and this is what I want to just show you in terms of the interpolation, so in between data points, you know, we are going to be guessing, right? So 366, 418, what could it be? You know, if you take the mean, okay, if you take the average of the two, so notice between these 2 points, so 366.28 plus 418.32, and so it's an average between them, and let's say if I divide by 2, okay, so what will we get? So 366.28 plus 418.32, and then divided by 2 just to get the average, so 392.3. So 392.3 I believe that's what it was. Yeah, okay. And that would be an interpolated data point that we would have. So now, is that necessarily true? Again, remember, you are guessing when you're interpolating, and that's not always true. And I want to just show you, okay, that it was actually way off. So notice that it actually was 330. So there was a huge drop from September, okay, the 4th to the September 8th, okay, quite a lot, almost $100 drop. And that's what happens. And because these are stock market values, it's unpredictable. You never know. So be careful, right? When you're in school, everything kind of looks nice and you can guess in between and so on. That's all wonderful. But the reality is, you know, in real life, not everything follows. There are some points, okay, for example, like in the stock market where you can't really make a guess. And a lot of people are guessing and they're just gambling away, right? Because they don't really know what will happen the next day. All right. And this shows that to you and tells you, you know, how far off you can be in between the points. So notice, okay, that and that, you know, so be careful, okay, with regards to that, and then interpolating data. And the same thing happens for extrapolating data. And especially in the stock market with prices, you know, people think that things are going to go up or things are going to go down when they're going down. But again, you never know, right? So if we were extrapolating this, right, and we continued on, you know, we would maybe think that this would kind of nicely head upwards. But is that the case? Nobody knows, right? This could have just simply started to come down again or whatever it may be. It's not always nicely linearly going up. And so that brings me to the point of discussion that in the next video we'll discuss kind of linear and non-linear, all right, and what that is. But from this video, you should understand and be able to follow certain trends when you are graphing things out, all right, on plots. You should understand what interpolating means and extrapolating means. And always remember that you are guessing when you're interpolating and extrapolating. All right, so thanks for watching. We'll see you in one of the future relations videos. All right, okay, cheers, bye.